I'm Kosta from Car Focus, and the car I've got here for you today is the Escape Hybrid, plug-in hybrid to be more specific. Today I'm going to be showing you what you need to know about plug-in hybrids, the Escape, and why you should consider a plug-in hybrid at all if you are going to be looking at buying one in the near future. We do cover quite a lot in these videos, so if there's something specific you want to look at, use the chapters to skip ahead in the description below. The plug-in hybrid is the next step in the evolution from hybrid to full electric vehicle. It's a step up from a traditional hybrid, but it's not quite an electric vehicle yet. It gives you that little bit of electric vehicle drive, efficiency and comfort, and it also gives you that knowledge that you can actually charge off the grid, but it is still heavily reliant on its internal combustion engine. Electric energy, this can only get you about 60 kilometers, and so you are on a typical day going to still probably be relying on your internal combustion engine. However, because it's got a slightly bigger battery than a traditional hybrid, roughly 16 kilowatt hour battery in the one we've got here today, it means that you can get a decent amount of electrical drive out of this vehicle and substantially reduce your fuel consumption versus a traditional hybrid or a internal combustion engine. To be more specific, this is published as low as 1.6 liters per 100 kilometers of fuel economy, and that is a relatively realistic number that I've actually managed to achieve while driving this vehicle. On previous videos, we've actually had comments where people have achieved less than 1 liter per 100 kilometers while driving one of these. It all depends on how well you keep that battery charged up, and if you've got a system and a rhythm in place so that every night when you go home, you're plugging it in, preferably after midnight when you're getting some cheap electricity off the grid, and you're getting some great efficiencies out of a car like this. If you keep the car to under 100 kilometers a day, you could reduce your trips to the fuel pump to 1 a month. Come with me while we take a closer look at the Escape Hybrid plug-in that we have here today. Looking at the front of the vehicle, there's not a lot that jumps out at you, and in fact there's nothing on the front of this vehicle that would indicate that this is a plug-in hybrid or hybrid vehicle. Looking at the front, because it does have an internal combustion engine, there's still the necessity to have a full air intake and a grille. In fact, this Escape is equipped with what is called an active grille. So behind here, there's actually a slatted grille that can open and close and control the amount of air that comes in through this front grille. Pretty clever technology, and it's used to control the heating and cooling of the engine better. The only other potential thing to look out for with the plug-in hybrid that you might be choosing is that the plug-in might be in the front. In this car today, it's not. So essentially, you've got a 1.5 litre petrol engine over there, you've got an electric motor over there, and below what they are both attached to is the gearbox, which then drives the wheels. So essentially, gearbox drives the wheels, and the engine or the electric motor can drive the gearbox. So they can do it simultaneously, and they can also do it independently of each other. If you've got full charge on the battery and you've got the car in automatic mode, where you're allowing it to make decisions about whether it's using electrical energy or mechanical energy, it'll be flipping between these two motors constantly so that you're getting the best efficiency out of both of them. Traditionally, it likes to use the electric motor on acceleration because that's where electric motors are a lot more efficient. And if you had to do long distance highway driving, the mechanical engine is probably a lot better and more efficient at doing that, and the car would switch over to that. Now, the Escape Hybrid does have 4 different drive modes, which we're going to go into a little bit more detail later. Whenever you see these thick orange cables in any electric vehicles, it means don't go anywhere near them. These are high voltage cables. They are very dangerous. Do not touch them. Do not go anywhere near them. And in fact, even in a franchised dealership or car dealership, the technicians that work on these cars have to be specially trained so that they know how to handle these high voltage cables. The first thing that's going to jump out at you is this little flap over here. This is the AC charger for the plug-in hybrid, and you can see it only accepts AC charge. It also has 2 separate buttons over here. The one is a timing charge, so it actually allows you to come home, plug in and set the timing charge button. The timing charge button will then revert back to the settings that you set in the onboard computer. All of that is if you're charging straight off the grid. Of course, if you've got solar panels and batteries at home and you've made clever use of electricity, then perhaps you can set different charge times. But the point is that this button allows you to set the times that the car draws electricity out of your home. The next one is just the unlock button, which you have to press in order to release the charger. This is the AC charger that comes with the vehicle that we have here today. On the one side, you've got your Type 2 AC charge connector, which allows it to plug straight into the car. And on the other hand, you've got a traditional wall socket plug, which allows it to just plug normally into the wall. This is what's called a Type 1 AC charger. It is the slowest way to charge the vehicle, but it does give you versatility in that you can literally just plug this into a normal wall socket in the house and charge your car. You can also get a type 2 AC charger. That one would have one of these on either end of the cable, and on the other end it would have to plug into a type 2 charger on the wall, which actually allows the vehicle to charge a fair bit quicker than the type 1. So the Escape can take a minimum of 95 RON fuel, so 95 or 98, and it can also take what we have here in Australia, E5 and E10, even further reduce your fuel consumption and improve fuel economy for this vehicle. So we've got the home screen. From the home screen you can either go to settings and charge settings, or you can go straight into this button here, which is your charge settings. Once you're in your charge settings, you can set up your charge preferences. Now it does give you a quick summary here. It tells us that our battery is currently at 76%. It tells us that how long it will take to charge when it's plugged in. So with a high voltage or type 2 charger, it reckons 0.9 hours to fully charge, or in a type 1, which is the one that just plugs into the wall, 1.4 hours to fully charged. So that does sound pretty quick, but that's obviously because we've still got a fair bit of charge in the battery. Now you can also set up your charge preferences here, your charge time setup. If you go in there, you can add a location, continue to scheduling. And the idea would be that you'd set this as home, and you would tell it on a weekday charge times and your weekend charge times. So ideally, for example, if you're only charging straight off the grid during the week, when you get home, you'd want to be charging off the grid late at night, preferably after midnight, where rates are cheapest. And then that brings up your time zones, and you can go PM or AM, and you can set the time slots in which you would want it to charge. So the green, anywhere in the green it will charge. So essentially all we're doing here is we're graying out the areas or the times where we don't want it to charge. So if this is 12 AM, that's where you want it to charge. So you don't want it to be charging during these really expensive charge peak hours, which is, you know, when everybody's home cooking dinner and all the lights are on and everybody's watching TV. So you'd want to gray those out, and you'd really want it to start charging at midnight. And that's sort of how you would set it up. Next, you could also set up your weekends. So weekends, depending on where you live and what your charge tariffs are, you might want to change or set up some different times there for weekends. And that's how you would set it. Now, once you've set this up, you would use the charge time button on the little charger where you plug in. Just press that button, and then it would only charge according to the times that you've set. The other button that I want to mention here for the hybrid that's unique to the hybrid is this one, your energy flow diagram. So at the moment we're in the car, we parked, the engine is idling. I say the engine, the car is idling. The internal combustion engine is actually off, and we're running just on battery power over there. If I were to change the modes from normal and put the car into EV charge battery. So in EV charge battery, I've now switched on the combustion engine, and I've told the combustion engine to please charge my battery. So that's exactly what it's doing. So that's another way to charge the battery. You can use the internal combustion engine to charge the battery. You don't have to plug it in to do that. So if I take it out of EV charge mode and just put it back into normal mode, you can see there now in normal mode, in auto mode rather, it's now saying, well, I'm not going to use the combustion engine to charge the battery. But it has chosen to leave it running anyway. So it's kind of running now off the combustion engine and the battery. So in all electric mode, you're telling it to have a preference for using the electric battery, but the vehicle still has an automatic function built in there, and under certain condition, if it decides that it does need the assistance of the internal combustion, even in all electric mode, it will still use it. Ideally, the electric batteries that run in these cars should never ever completely run out of charge. So this is the car, the systems and the computers are designed to make sure that if that battery is ever getting critical, or if the charge or load on that battery is too high, to engage the internal combustion engine and make sure that it's constantly giving the battery a little bit of charge when it needs it. You also have an EV later mode. So EV later mode means that I want to save the energy in my battery so that I can use it later. The times that you would use EV later is if you're doing a long distance trip. The internal combustion engine is a lot more efficient at constant speeds. So if you're on the highway doing constant speeds, you'd want to be favoring the internal combustion engine anyway. So you can put it in EV later mode, and in that mode it will use the internal combustion engine and save the battery for later, when you maybe get back into a city and you get back into stop-start traffic, which those conditions are more favorable for the battery and the electric motor. All right, so just looking on the inside of the vehicle, we've got the full digital display instrument cluster over here. Just above that, the heads-up display, and the center display as well as another touch screen that sits just there. So we've got them all on display here for you today, and I'm going to try and talk you through some of the important parts that you'd want to know with this being a hybrid vehicle. So the first thing to mention is our fuel range. So we've got the traditional 658 kilometers on our full tank of fuel. Next to that is 41 kilometers on our battery. So those are the two different ranges. If we were to drive just on the battery, we should get 41 kilometers. If we were to drive just on the fuel, 658. So a combination of the two means we should be able to get a little bit better than that. As is common now with hybrids and electric vehicles, as soon as you switch them on, the little ready light comes on to let you know that they're ready, because there is no internal combustion engine making a noise. On the right hand side, where you'd normally have a rev counter, this car doesn't have a rev counter. Instead, it's got your power indicator, and we'll be keeping an eye on that one as we start to drive, because it's got the battery icon and the engine icon, and it's got the zero, and it's also got below zero. So below zero is when we go to regenerative braking. That's when we're actually getting energy back from the car into the battery. And then of course when we go past the zero mark, that's when we're using energy either from the battery or the internal combustion engine. So this particular car I've been driving since new. It's only done 224 kilometers from date of birth. And we can see here I've never reset trip computer number one. So trip computer number one has got a total of 212 kilometers. It's averaged 2.6 liters per 100 kilometers. And it's done 184 electric kilometers. So you can see they're pretty efficient use of the electric system and the battery, and the majority of our mileage has been done electric. It's currently sitting at 2.6 liters per 100 kilometers. That will average down over time, especially if we maintain this electric to total mileage ratio that we have been achieving. The next screen is our fuel economy screen. Again, it just gives us our current average and that we're currently in electric driving. Tire pressure sensors, your eco behavior, which gives you acceleration, deceleration and speed. And it's just basically telling me that I've been driving this car economically. There's our electric efficiency. So we're doing an average of 17 kilowatt hours per 100 kilometers, which then estimates our range on the next full charge to 61 kilometers, which is about right, because the car's got about a 16 kilowatt hour battery. Right, the next one is the EV coach. Now this one, in order to demonstrate this one, we are going to have to drive. As I take my foot off the brake, it goes into electric mode. Now the EV coach is showing us constantly what is actually happening and what power source the vehicle is actually using to drive. This is also displayed diagrammatically using the center screen there. So now we're on a downhill, and you can see it's saying, the EV coach is saying we're charging, and the charge has gone green, and our little power meter on this side is going more and more into the negative the more I charge. Now when you're in this charge mode here, and then you come to a complete stop, it says 100% energy return. So I get a little gold star. 100% means that I didn't use my traditional brake calipers at all. So the brakes were not used, the mechanical brakes were not used at all. We actually came to a complete stop there using just the regenerative braking. So I've done two things there. I've converted the maximum amount of kinetic energy back into my battery that I could have possibly done on that little brake, while simultaneously not using my mechanical brakes, so zero wear and tear for me. So your foot is still touching the pedal, so you're still using the brake pedal, but you're not using the actual brakes. Car's making the decision which brakes to use, either regenerative braking or the brake calipers. Now you'll see as we pull off, it's gone into electric mode again. I am going to brake a little bit hard this time. I'm just also warning Jerry, my cameraman, so as soon as I do a slightly harder brake, it overruns there. I don't know if you saw that, but it overran the green light and it went grey. That means that it would have used the brake calipers ever so slightly. And if you were to come to a complete stop, so I'm just going to do another relatively hard brake. And there we go, we overran it. And you'll see now I'm not going to get 100%. I only got 69% energy returned. It means on that particular brake, where I braked a little bit harder, the regen braking wasn't good enough and it actually engaged the calipers. Alright, so if I were to change over from the normal, well, we're not in normal, we're in auto. So if we go from auto, normal, which is auto EV, and we go to EV only, I actually want to go to EV later, rather EV charge battery. So let's just go to that mode, because I want the combustion engine to switch on now. So you can see in our normal, in our center console here, that the combustion engine's now on. It's also sending power to the battery, so it's actually charging the battery. and it's doing all of that while we're driving. You can hear the car's still pretty quiet. What it has done though to our EV coach has now gone into what it calls hybrid mode, and it's all grayed out. In hybrid mode, it means that it's using the internal combustion engine and the battery simultaneously, but primarily just the internal combustion engine. So you can see how diagrammatically how our EV coach has changed. However, when I take my foot off the fuel pedal and I start decelerating, it automatically goes into charge mode. So it's constantly trying to absorb as much of that energy as it can and store it away for us. So as we pull off, EV coach is still in hybrid. So if I were to flip over into EV only, it still says engine enabled for system performance. So even in EV only, it will still keep the engine on standby. But now you can see the EV coach has changed back. So what I've realized that from auto mode versus all electric mode, they pretty much behave very similarly as long as you've got a decent amount of charge in the battery. So as long as you've got a decent amount of charge in the battery, even in auto mode, the car is favoring the electric energy rather than the mechanical energy. In normal mode, it's still favoring electric drive, and similarly, if you go into electric mode, it will still keep the combustion engine on standby. So if you were to accelerate suddenly, which I'm going to do here now, so if I accelerate suddenly, there you see it maxed out that electric bar for me, and it didn't quite use the combustion engine there either. But I have found that if our battery is on a lower charge, that blue bar becomes shorter. So that blue bar is nice and long at the moment because we've still got a healthy amount of charge in the battery. So if you accelerate too hard and the electric motor can't do what you want it to do, even in all electric mode, it will still engage the combustion engine to give you that extra power that you're asking for. So it's pretty sensitive, and it's taking the feed off the accelerator pedal and the rate at which you're accelerating to make decisions as to which power source it uses. So even if you want to stay all electric, the car is still going to use the combustion engine under certain circumstances, and you can't always judge when it's going to deem it necessary. There's many plug-in hybrids available on the market today. More specifically in Australia, we managed to get the Escape plug-in hybrid for this video today. There are more, so if there's any other ones you'd like us to do a video on, leave that in the comments and description below. Thank you for watching this video, and don't forget to subscribe.